Today we're going to learn how to graph a function given its equation. So here we have y equals 3 the sine of 1/2 times x minus pi over 6 minus 4. So if you remember in the past that we usually deal with equations, sinusoidal functions in this form, where y equals a, which stands for the amplitude, sine or cosine of b, which stands for the number of cycles in 360 degrees, or 2 pi radians, times x minus c, c being the shift horizontally, or what's called the phase shift, and finally d, which is our shift vertically. So we need to find all 4 of those values, and why don't we start? First thing we should notice here that our value of a is 3. Our value of b is 1/2, which is the number of cycles in 2 pi radians. And a was our amplitude. Our c, which is our phase shift, is pi over 6. And finally, d, which is our shift vertically, is -4. So let's try to graph this. It's usually best to graph by using the midline first. So since our midline is d, which is a -4, because it's been a shift vertically down 4 units, here's our -4, and we'll just do a little sketch of the midline. Now we know the amplitude is 3, which means the graph will never go any higher than 1, 3 units up, and 3 units below, which would be here at -7 and -1. Okay, now we want to look at our phase shift, and it's at pi over 6. So we'll make this first unit here at pi over 6. And we know that a sine always starts at the midline and goes up. So we know it's going to start here and start increasing. And before we could do too much, we really should look at what the period is, because we need to know the difference between the point where it hits the midline and the maximum point, and from the maximum point back to the midline, and so on. Well, we know that the period is always equal to 2 pi radians, which is 1 full cycle, divided by b, which is 2 pi over 0.5, which is 4 pi. And so since the period is 4 pi, we need to break that into its 4 equal segments, so we know how long the distance will be between the minimum point and the midline to the max point, and so on. So that's called our best scale. And our best scale simply takes our period and divides it by 4. That tells us that our sine curve will be broken up to 4 equal parts of pi units. So if you remember, we put down pi over 6. If you might have noticed, I just recalibrated our axes to make it a little bit easier to look at. And we know that the next time where it hits a maximum point, which will be at -1, will be pi units over to the right. So since pi units is over here, pi over 6 will be a little bit past that. So it's going to be somewhere over here. And this distance here, or this right here, will simply be pi units over plus pi over 6. Which, if you do your calculations, you know that pi is the same as 6 pi over 6, so this becomes 7 pi over 6. Now we want to come back down to the midline. There'll be another pi units over, so that one will be a little bit more than 2 pi, so it should come down to something like that. And this point over here will be simply our 7 pi over 6 plus another pi units. And since pi units is the same as 6 pi over 6 units, we get 13 pi over 6. And that is that point right there. Keep in mind, what we're doing is going by in increments of pi. So we started pi over 6, we added pi, units to get the maximum point, and then another pi units to get to the midline, and now another pi units will get us down to the minimum point. We know it's at -7, and it'll be something like this. And this distance here, this x-coordinate, will be another pi units over. So if we add pi units to 13 pi over 6, since pi is 6 pi over 6, and 13 pi over 6 gives us 19 pi over 6 units. Notice once again, each distance is pi units. And then finally, we want to go back to the midline again. So we're going to come back up to the midline, which would be somewhere around there. And that will be another pi units over, which is 19 pi over 6 plus 6 pi over 6. That's 25 pi over 6, and that would be this point right there. And the important part to notice here is, once again, as I was saying, the distance from here to here is pi units. From the maximum point back to midline is pi units. From the midline to the minimum point would be pi units. And from the minimum point back to the midline is pi units. And we got the pi units because we knew the period was 4 pi, and which we did over here. And we divided into 4 equal parts. That's how we got our best scale of pi units. And that's it. So all these problems are very similar. You need to find A, B, C, and D. Then you need to sketch the midline, make sure you know the amplitude, figure out the period and the best scale. So hope that's clear. So now it's your turn. What we'd like you to do is graph the following function, the same way we just did the previous one. So pause it, copy it down, and good luck, and see you again next time.